So guys, welcome to our channel once again. In today's video, we have here these 9 questions to answer on the topic magnetic field. So guys, this video will be about current carrying conductor in a magnetic field. So in short, to stay till the end of this video. Let's go ahead and start with the first question here. It says, the force experienced by a current carrying conductor moving in a magnetic field is employed in the working of the I. Moving coil ammeter, II. Electric bell, III. Electric motor. Which of the statements above are correct? We have A. I and II only. B. I and III. C. I and III only. D. I and III only. So guys, the answer to this question is option D here, I and III only. So the force experienced by a current carrying conductor moving in a magnetic field is employed in the working of a moving coil ammeter and an electric motor. So that's it for this question. Let's go ahead and consider the next question, guys. So that's question number 2 here. It says, a bar magnet is placed near and lying along the axis of a solenoid connected to a galvanometer. The pointer of the galvanometer shows no deflection when A. the solenoid is moved away from the stationary magnet, B. the magnet is moved away from the stationary solenoid, C. there is not relative motion between the magnet and the solenoid, and D. the magnet is moved towards the stationary solenoid. So guys, the pointer of the galvanometer will show no deflection when there is no relative motion between the magnet and the solenoid, and that's option C here. So that's it for this question. Option C is the answer to this question. Let's go ahead and consider the next question, guys. So the next question here is question number 3 here. It says, the relationship between the directions of the magnetic field, the current, and the motion of a current carrying wire in the field is easily remembered using A. Maxwell's screw rule, B. Fleming left-hand rule, C. right-hand grip rule, and D. octet rule. So guys, the answer to this question here is option B here, and that's the Fleming left-hand rule. So that's it for that question. Option B is the answer to the question here, Fleming left-hand rule. So let's go ahead and consider the next question, guys. So here is question number 4, and it says, the direction of motion of a current carrying conductor placed within the opposite poles of a magnet is determined using A. Maxwell's corkscrew rule, B. Fleming's right-hand rule, C. Ampere rule, and D. Fleming's left-hand rule. So guys, the answer to this question here is option D, Fleming's left-hand rule. So let's go ahead and consider the next question. So that's question number 5 here. It says, two straight current carrying conductors are placed near each other. Which of the following diagrams correctly illustrates the magnetic field pattern formed by the conductors? So guys, looking at this, the magnetic field patterns that is formed by the conductors is that shown in option A. So option A is the answer to this question. When two straight current carrying conductors are placed near each other, they will form a magnetic field pattern as shown in option A. So that's it for this question. Let's go ahead and consider the next question, guys. So guys, the next question we have here is question number 6. It says, in a mass spectrometer, an ion charge Q and mass m moving in a path of radius r in a field flux of density B has a spread of A MQ over QR, B BQR over M, C MQ over BR, D MR over QB. So guys, let's take note that the force on a moving charge in a magnetic field is related as F is equal to QVB. So while the centripetal force is F is equal to mv square over r. So guys, if we equate the two here, we're going to have that QVB is equal to mv squared over r. So in that case, if we go ahead to resolve this, we are going to have QVB times r is equal to mv squared. So if we make v the subject of this equation and rearrange this, we are going to have v is equal to BQR over M. So that's it for this question, and option B is the answer to this question, BQR over M. So that's it. Let's go ahead and consider the next question, guys. So that's question number 7 here. It says, if the direction of the current in a straight wire is reversed, the magnetic field A becomes parallel to the wire, B ceases to exist, C remains the same, D is oppositely directed. So guys, if the direction of the current in a straight wire is reversed, the magnetic field is oppositely directed, and that's option D here. So option D is the answer to this question. Let's go ahead and consider the next question, guys. So that's question number 8 here. It says, which of the following statements about a straight current carrying wire placed in a uniform magnetic field is correct? The wire experiences A, no motor force if parallel to the field, B, maximum motor force if the current reverses its direction, C, a motor force with constant direction if either the current or the magnetic field is reversed, D, no motor force if it is perpendicular to the field. So guys, the answer to this question is option A here. The wire experiences no motor force if it is parallel to the field. And that's it for this question. Let's go ahead and consider the next question, guys. So guys, the next and the last question here is question number 9. It says, current is passed through two parallel conductors in the same direction. If the conductors are placed near each other, they will A, move in a circle, B, remain stationary, C, attract each other, D, repel each other. So guys, the answer to this question is option C here. If the conductors are placed near each other, they will attract each other. And that's it for this question, guys. And this is where we'll end this video for today. If you enjoyed this lesson, please give it a thumbs up. Don't forget to subscribe to this channel if you're not yet a subscriber. Also, if you have any specific question regarding this video, you can drop your question on the comment section below, and we'll ensure to give you a response. So finally, guys, we want to encourage you to join our YouTube channel community. So you can join the channel community by hitting the join button below, and we'll see you right there. Thank you once again for watching this video, and see you on the next one.